Welcome to section 413. We're still talking about graphing parabolas without a table using these transformations. So there's our general form of a quadratic, y equals a times the quantity of x minus h squared plus k. Called the vertex form as well because the vertex is at h, k. Remember, watch your signs for h. And the axis of symmetry, x equals whatever h is. Now, for the other values, when a is less than 0, that's our x-axis reflection. When the absolute value of a is greater than 1, that means we have a vertical stretch. When the absolute value of a is between 0 and 1, we have a vertical compression. And our values for h. H, that's our shifting left if it's a negative, right if it's a positive. And k is our shift down if it's a negative and up if it's a positive. All right, so looking at this, we're looking at the parent function y equals x squared. Oh, and keep in mind, y equals x squared, our anchor points. We use these for all of our quadratics. -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Those are the anchor points we use each time. All right, so for the following, we're going to state the transformations from the parent function and the vertex, line of symmetry, domain, and range, all without using our calculators. So looking at this, a, h, and k. A is 1, that's our leading coefficient. H is a -9, we have to change the sign, and k is 0. So what that's telling us is that all we're doing, our only transformations, is we're going to shift left 9. So looking at this, our vertex is at -9, 0. Our domain, axis of symmetry, we'll do that first. Axis of symmetry, we know that already as well. X equals -9. Now for our domain and range. Our domain and range. I'm going to make a quick sketch without even using a calculator. Now I know from the origin I'm shifting to the left 9, and parabola opens up. So that's all I need for my domain and range. My domain for all of these is all real numbers, and my range, y is greater than 0. For number 2, I want to identify a, h, and k. A, the leading coefficient is 1. H is in parentheses. There's no parentheses here, so h is 0, and k is the number at the end. It's 7. So that means the only transformation that's occurring is we're going up 7. So our vertex is going to be at 0, 7. The axis of symmetry, x equals 0. Domain and range. I'm going to make a quick sketch. I know I'm going up 7 and my parabola opens up. So my graph is going to look like this. So my domain, all real numbers for all of these, and my range, y, is greater than or equal to 7. Problem number 3. A is 3. That's our leading coefficient. H is in parentheses. There's no parentheses. K is the number hanging out at the end. There is none. So it's 0. So the only thing we have is a vertical stretch of 3. So we can identify our vertex. It's at 0, 0. That's h and k. The axis of symmetry, x equals 0. Just to help me visualize a little bit, my domain and range. Nothing shifting left or right. All it is it's opening up faster. It's got that vertical stretch. So my domain, still all real numbers, and my range, y, is greater than or equal to 0 because it starts at 0 and goes up. Number 4, A, is 1/3. H, watch your signs, it's a positive 1. And K is 0. So with A, we have a vertical compression. It's going to open up wider. And H is 1, so we're going to shift right 1, because it's a positive. So now our vertex is at 1, 0. Our axis of symmetry, x equals 1. Now for our domain and range, I want to look at the sketch first before I say it. Now, all we're doing is we're going to the right 1, and it just opens up a little bit wider. I don't need to be exact for it. I just kind of need to know where my vertex is and if it's opening up or down. So my domain stays all real numbers, and my range, y is greater than or equal to 0. I'm getting all of these just by knowing what A, H, and K are. That's how powerful it is once you understand it. So for number 5, A, the leading coefficient is -1. H, watch your signs, is a 7. And K is a positive 6. So we got a little bit more going on here. We have an x-axis reflection. H is 7, so it means we're going to the right 7. And K is 6, that means we're going up 6. My vertex, 7, 6. Axis of symmetry, x equals 7. Now our domain and range. I like to visualize this. Now I know my vertex is at 7, 6. And because A is negative, it's opening down. Now you can see I'm not being real exact with my graph. I'm just kind of roughly estimating where those points would be. Now our domain remains all real numbers. And our range. All of our values for y are going to be less than or equal to the y coordinate, 6. Number 6, A is -2. H, watch your signs, is -3. And K is -8. So what we have here for A, there's an x-axis reflection. And it's also causing a vertical stretch. Both of those are occurring because A is not just a negative, but a -2. H, the -3, we're going to the left 3. And K is -8. That means we're going down 8. So I know where my vertex is. It's at -3, -8. My axis of symmetry, x equals -3. My domain, I know for all of my quadratics, it's always going to be all real numbers. I don't even need to see that to know that because it's the same for all. Now, if you were to sketch the graph, I'm going to go to the left 3 and down 8. Let's just say it's down here. Because of the reflection and the stretch, it's going to look more like this. So now the vertex is at -3, -8. So the range, all of our values for y are less than or equal to -8. They start at the -8 and they go down. And we knew that just from knowing our values for A, H, and K. Let's go to problem number 7 and number 8. We're going to actually graph these using the same things we've talked about before. So for number 7, I want to list what A is, what H is, and what K is. A is 1. H is a 5. Be careful of your signs. And K is a 3. So with A, nothing happens. H is 5, so we're going to the right 5 because it's a positive. And K is 3, so we're going up 3. Now, I'm going to mark my anchor points. 0, 0, 1, 1, 2, 4, 3, 9, negative 3, 9, negative 2, 4, negative 1, 1. Now, I'm going to take each point and go to the right 5 and up 3. To the right 5, up 3. I'm going to use a little X to mark that point. To the right 5, up 3. Right 5, up 3. Right 5, up 3. And the other point's just a little bit too high off the graph. Actually, we could do that. Went over too far. Sorry. And there is our graph. The vertex is at 5, 3. We knew that even without graphing it. The axis of symmetry, x equals 5. The domain for all of these, it's all real numbers. And the range, our y values, they start at 3 and they go up, so y is greater than or equal to 3. Now let's find the intercepts as well, even though it doesn't say it. Now the x-intercept, you can see the x-intercept, it's above the x-axis, so there is none. The y-intercept, I don't know exactly where that's going to be, but it looks like it's going to cross the y-axis at some point. Algebraically, remember, the y-intercept is when x is 0. So y equals the quantity of 0 minus 5 squared plus 3. So it's going to be negative 5 squared plus 3. So it's 25 plus 3. So y is 28. So the y-intercept is at 0 and 28. And now, number 8, the last one. A is negative 2. H is a negative 3. Watch your signs. And K is a positive 2. When A is negative 2, because it's a negative, there's an x-axis reflection. And there's a vertical stretch. H is negative 3, so we're going left 3. K is 2, so we're going up 2. All right, anchor points, 0, 0, 1, 1, 2, 4, 3, 9, negative 3, 9, negative 2, 4, negative 1, 1. Same every single time. Now, with the A being negative 2, what we can do to take care of both of those at once is multiply the output, the y coordinate, by negative 2. 0 times negative 2 is 0. I'm using a little x there. 1 times negative 2 is negative 2. Same thing over here. 4 times negative 2 is negative 8. Same thing on the other side. And that's good enough for us. The other one's way off the graph. Now I'm going to take each point. I'm going to go to the left 3 and up 2. So left 3, up 2. I'm going to use an open dot just to differentiate. Left 3, up 2. Left 3, up 2. Left 3, up 2. And those open dots, I'm going to draw my parabola through those points. And there's a sketch of our graph. So our vertex, we already knew where it was going to be. It's going to be at negative 3, 2. our axis of symmetry, x equals -3. Our domain, we knew that because it's always the same for a parabola. It's all real numbers. And our range, y in this case is less than or equal to y is less than or equal to 2. Now my x-intercepts, I can actually see my x-intercepts. They're -4, 0 and -2, 0. My y-intercept, I don't see. I'm close to it, but I'm not exactly sure where it is. So we can find the y-intercept by putting 0 in for x. So y equals -2 times 0 plus 3 squared plus 2. -2 times 3 squared plus 2. 3 squared is 9. -2 times 9 plus 2. So y equals -18 plus 2. Y equals -16. 0, -16. And there we go. Now, there's different forms. Actually, we'll talk about that in the next video. And I will see you for part 2 of section 413. Thank you.